Hi. In this third presentation of the UART playlist, we will look at the ASMD chart and the VHDL coding of the receiving subsystem. So after watching this presentation, I hope that you will be able to explain the ASMD chart for the receiving subsystem and its corresponding VHDL description. The receiving subsystem is itself a finite state machine with data path, and as such its behavior can be represented by an ASMD chart as shown here. This chart is not very complex and comprises only 4 states which are closely related to the 4 fields that were indicated in the RS-232 frame format. And that is because we are not using a parity bit in this case. So the first state, which is called idle, is where the FSMD remains after each stop bit while it is waiting for the next byte to start. As soon as a logic 0 is detected on the received data line, we know that we have started to receive a start bit for the next byte, and so the control path of the FSMD resets the sampling ticks counter and moves on to the start state where it increments the sampling ticks counter for every sampling tick received from the baud rate generator. When the sampling ticks counter is equal to 7, we have reached the middle point of the start bit. So it is now time to reset the sampling ticks counter and also reset the data bits counter, and to move on to the data state where we will remain until all data bits have been read. In the data state, we again increment the sampling ticks counter for every sampling tick received from the baud rate generator. But now we wait until this counter reaches 15 instead of 7, since we want to go from the middle point of one bit period to the middle point of the next bit period. So when the sampling ticks counter reaches 15, we know that it is time to reset the sampling ticks counter and to deserialize another bit. And deserializing in this case means reading the value that is present at the received data line and inserting it into the deserializer register. And of course, then check if this is the last data bit to be received. If not, we must, of course, increment the data bits counter and re-enter the data state where we will remain until all data bits have been read, as I have said. So this process will be repeated for as many data bits as there are in the defined RS-232 frame, and it's only when the last data bit has been received that we will move from the data state into the stop state, where again we will count the number of sampling ticks until reaching the middle point of the stop bit. And on that moment, or at that moment, we will assert the received on tick output for 1 clock cycle and restart the whole process by going back to the idle state, where we will wait for the detection of the next start bit. So the VHDL description of the UART receiver can now be built quickly from the ASMD chart that has just been presented. And the entity and the signals declared in the architecture body are presented in this slide, which will be followed by one slide addressing the state and data register segment, and then by 4 slides presenting the next state and data path segment, where each slide corresponds to one ASMD state. There is not much to say here, where the entity uses a generic declaration to define the number of data bits and the number of sampling ticks that are needed to read the stop bit. Notice that the counter signals at the bottom in the architecture body, the counter signals, both the sampling ticks counter and the number of data bits counter, have to be defined or declared as unsigned, since we need to perform arithmetic operations over these signals. But the deserializer signal may be declared as standard logic vector, since this data type supports the operations that we will use for shifting. And we have, of course, the user-defined data type needed to represent the control path states and the corresponding state register and state next signals. So this slide shows the FSMD state and data register segment, and it also contains the usual code for initializing the register structures when the asynchronous reset input is active, or to otherwise to move them on to their next state. The next state and data path segment starts with the default value assignments, as you see here, followed by the code for state idle. Please ask me if you don't know the answer to this question, and take notice of the signals that are represented in the sensitivity list of this process. There is not much to say either in the start state VHDL description, but you may pause the video and check that the VHDL code is a direct replica of the ASMD chart block for state start. Likewise for state data, but here I would like to call your attention to the statement that implements the deserializer here at the middle. Notice that the deserialize operation is carried out by concatenating the logic value that is present at the received data line and the 7 leftmost bits of the current content of this register. So, in other words, the 7 leftmost bits of the deserializer are shifted 1 position to the right. What was previously the rightmost bit is discarded, and then the leftmost position is filled with the logic value that was read at the received data line. Please pause the video here for a moment and take your time to go through the code and the ASMD chart. And finally, the stop state is presented in this slide, where you can easily set up a direct equivalence between the VHDL statements and the ASMD chart boxes on the right. And that's it. Thanks for your attention.